Hello everyone, I am Karthik from ITA section and my roll number is 1230. Today on concept video my topic is about extensial quantifier with an example. Let us see what is extensial quantifier and what are its examples in further slides briefly. Let us go into our slides. Extensial quantifier. In predicate logic, an extensial quantification is a type of quantifier, a logical constant which is interrupted as there exists. There is at least one, or for some it is usually denoted by the logical operator symbol, which when used together with a predicate value is called an extensial quantifier. Extensial quantification is distinct from universal quantification, which asserts that the property or relation holds for all members of the domain. Some sources use the term extensialization to refer to extensial quantification. So, uh, the extensial quantification is a type of quantifier where a logic constant which is interrupted as there is at least, or for some it is usually denoted by logical operator symbol there exists. So this is a basic definition uh, of extensial quantifier. Let us see some more slides. Consider a formula that states that some natural numbers multiplied by itself is 25. Let us take 0 into 0 equal to 25, or 1 into 1 equal to 25, or 2 into 2 equal to 25, or 3 into 3 equal to 25, and so on. This would seem to be a logical disjunction because of the repeated use of or. However, the and so on makes this impossible to integrate it as a disjunction in formal logic. Instead, the statement could be rephrased more formally as, for example, for some natural numbers n comma n into n equal to 25. This is a single statement using extensial quantification. This statement is more precise than the original one, since the phrase and so on does not necessarily include all natural numbers and exclude everything else. And since the domain was not stated explicitly, the phrase could not be interrupted formally. In the quantified statement, however, the natural numbers are mentioned explicitly. So, by using n into n equal to 25, this single statement, using extensial quantification, this statement is more precise than the original one. So, but rather than using all the natural numbers, we can use n into n, so that the statement gives more precise than the original one. So, and since the domain was not stated explicitly, the phrase could not be interrupted formally. This helps in extensial quantification. This particular example is true because 5 is a natural number, and when we substitute 5 for n, we produce 5 into 5 equal to 25, which is true. It does not matter that n into n equal to 25 is only true for a single natural number 5. Even the existence of a single solution is enough to prove this extensial quantification as being true. In contrast, for some even number n into n equal to 25 is false because there are no even solutions. So, the example we take n into n equal to 25. When we substitute 5 as natural number in this n, we can produce 25, which is true. And in coming to even numbers, if we substitute, we can get a 25, and it becomes false because there are no even solutions uh, in the above statement. So the statement when we take even values at in the place of n, it becomes false. The domain of discourse, which specifies the values the variable n is allowed to take, is therefore critical to a statement's trueness or falseness. Logical conjunctions are used to restrict the domain of discourse to fulfill a given predict. For example, for some positive odd number n into n equal to 25 is logically equivalent to for some natural number n is odd and n into n equal to 25. Here and is a logical conjunction. So when we take and in between n is odd and n into n equal to 25, we are using and. So here and becomes logical conjunction to the statement we provided before. So and is an logical conjunction. In symbolic logic, there exists a rotated letter E in a sans font is used to indicate existential quantification. Thus, if P of A, comma B, comma C is the predicate A into B equal to C and a natural number n is a set of natural numbers, then there exists n belongs to n. P of n comma n comma 25 is a true statement. For some natural numbers n comma n into n equal to 25. Similarly, if q of n is predicate, n is even, then there exists n belongs to n q q of n and p of n comma 25 is the false statement. For some natural numbers, n is even and n into n equal to 25. In mathematics, the proof of some statement may be achieved either by a constructive proof which exhibits an objective satisfying the sum statement, or by a non-constructive proof which shows that there must be such an object but without exhibiting one. Rules of inference. A rule of inference is a rule justifying a logical step for hypothesis to conclusion. There are several rules of inference which utilize the extensial quantifier. Extensial introduction concludes that if the propositional function is known to be true or for a particular element of the domain of discourse, then it must be true that there exists an element for which the proposition function is true. Symbolically, P of A gives rise to there exists X belongs to X P of A. P of X. Extensive instantiation, when conducted in an Fitz-style deduction, proceeds by entering a new subderivation while substituting an extensial quantified variable for a subject which does not appear within an active subderivation. If an conclusion can be reached within this subderivation in which the substituted subject does not appear, then one can exit the subderivation with that conclusion. The reason behind extensial elimination is as follows. If it is given that there exists an element for which the proposition function is true, and if a conclusion can be reached by giving that the element an arbitrary name, that conclusion is necessarily true as long as it does not contain the name. Symbolically, for an arbitrary C and for a proposition Q in which C does not appear. There exists x belongs to x p of x uh, gives rise to p of c gives rise to q gives rise to q. P of c gives rise to q must be true for all values of a c over the same domain x. Else the logic does not follow if c is not arbitrary and is instead a specific element of domain of discourse. Then the starting p of c might unjustifiable give more information about that object. This is about extensial quantifier. Thank you all.